I'm Engineer Tolentino. Welcome to Polytechnic University of the Philippines, Santa Rosa Campus. Here's another video presentation from 2014 graduating batch of Electronics and Communication Engineering. I hope you enjoy watching this video.
Hi, I'm Jeremy,
Nishiko,
Melvin J.
RD, and I'm Melvin. We are the representative from the Polytechnic University of the Philippines, Santa Rosa Campus.
We are here to present our thesis study under the supervision and advisory of Engineer Rosalito E. Tolentino.
Our study is entitled
Design and Implementation of Head-Mount Controlled Aiming
System.
Shooting is an activity which requires stability and accuracy. It is known that shooting ability is greatly affected by the involuntary movement of the wings. As one tries to hold something still at arm's length, it is probably successful at first. But at some point, the stability of holding will not be maintained. Eventually, the arm will finally reach the point where it will not maintain the required position, which causes the shooter to miss the target. The problem arose in this case is that the act of triggering interferes with aiming and distorts the accuracy of shooting. That is, whenever the shooter concentrates on sight alignment, primarily other factors that concerning the stability of aiming will be affected. In other words, the accuracy will suffer. That's why the proponents aim to separate the process of aiming and the process of triggering by implementing controller to manipulate the aiming process, replacing direct intervention. ROSE simply stands for Common Remotely Operated Weapon System. ROSE has successfully removed the direct intervention of the human hand by using joystick as its controller. But using such controller, both aiming and shooting are still processed using the human hand. Motion and stability is achieved by neck musculature and controlled by feedback from the muscles themselves and the visual and vestibular system. Head motion is very dependent on the application being performed. It is also complex. It can be very ordered one minute and very chaotic the next, making prediction very challenging. If the mechanics of the head are considered part, it is possible to infer other characteristics of head motion. There is limited force that can be applied by the neck musculature to the head, which has mass and therefore inertia. Thus, it is reasonable to expect the voluntary head motion will be smooth. When viewing different objects, the arc traced by the head is that of the shortest length and therefore the most efficient path. The angular speed of the head illustrates the head motion is symmetric. This is because muscles used to accelerate the head are also used to slow it down. Thus, the same amount of time is taken. The proponents use Arduino, an open source electronics prototyping platform based on flexible, easy-to-use hardware and software which is intended for artists, designers, hobbyists, and anyone interested in creating interactive objects or environments. SolidWorks, a 3D mechanical CAD program that runs on Microsoft Windows and is currently used by over 2 million engineers and designers at more than 165,000 companies worldwide. LabVIEW, short for Laboratory Virtual Instrument Engineering Workbench. It is a system design platform and development environment for a visual programming language from National Instruments. It is commonly used for data acquisition, instrument control, and industrial automation on a variety of platforms. With the use of LabVIEW interface for Arduino, aka LIFT, a module that allows users to control sensors and acquire data through an Arduino microcontroller using the graphical programming environment LabVIEW. The proponents was able to integrate the three applications and simulate the movement of the mechanism with respect to the sensor. In order to fulfill the proposed solution, the proponents need to design a controller and a mechanism that is suited for aiming systems. The first objective is to implement a head-mount controller that will be mimicked by the mechanism for the proposed aiming system. The wearable controller must be appropriate to the head to be able to acquire pitch and yaw motion from the wearer's head movement. The proponents preferred a hard hat type helmet as the head lift for the controller. The distance and the weight of the display and the response of the sensor is considered mainly for the construction of the design. The second objective is to design a stable mechanism. The design is based on a typical centrican for it resembles the movement of human head when it comes to trajectory in. Pitch and yaw movement of the head were only considered for these are necessary movements in the in. The proponents considered the range of motion of the human head along the center of mass of the record to acquire the needed height for the pitch mechanism. The dimension of the pitch mechanism depends on the Herzog type volume, and the dimension of the yaw mechanism depends on the pitch mechanism's dimension.